Hello everyone. So today we are on day 17 of our DSA challenge, and the question that we're going to solve today is grid unique paths, right? I'm sorry, I haven't even opened the question yet. So this is how the question look. Just let it load. So basically, this question requires you to understand how basically see. I'll tell you one thing. This question is particularly based upon you know, there are two things that this question is based upon. First is simple math, that is permutation and combination, through which we will be solving our final, you know, the final algorithm, which we will implement here, the final solution that we will implement here. But this question needs you to understand what dynamic programming is, what recursion is. What I'll do is I will not write the dynamic programming code here or the recursion code here, but I'll make you understand how you can hit this question with sorry, with recursion, and then you can probably convert it into dynamic programming. We'll go till memorization. I won't give you basically. I obviously I can tell you how tabulation works and then how space optimization works as well. But the main point of this question, where what I can think of why Striver has put it in array partly and not in, as you can see, there is a different day for dynamic programming, is that because this question is particularly based upon what do you call the permutation and combination and not exactly on the dynamic programming. But yeah, dynamic programming is one of the solution. But last thing is these kits are generated so that the answer will be less than or equal to 2 to the power 10, 2 into 10 to the power 9. So basically that is the limit. I think probably here, okay, this is a minute, doesn't matter. So yeah, I mean, you don't need to basically understand what dynamic programming is. What I'm thinking of is I can probably have a separate day for few dynamic programming questions. Though I think when we'll be ending our day 30, we'll be covering this linked list only. But what I'm trying to do is I will start with recursion and working, and then probably dynamic programming, because that is one very important thing to learn about. So without further ado, we'll just get into the code. Get into the question. There is a robot on an M into N grid. The robot is initially located at the top left corner. That is the grid 00. The robot tries to move to the bottom right corner. That is M minus N, N minus 1. M minus 1, N minus 1. The robot can only move either down or right at, at any point in time. Given the two integers, M and N, return the possible return the number of possible unique paths that the robot can take to reach the bottom right corner. Great. So what we can do is we can just simply, um, copy this image and I can paste it here. Right? I can paste it here. Sorry. Mm, So if I move it a little here, you will notice that this is 0, this is 1, this is 2, this is 0, 1, 2, 3, 4, 5, and 6. Right? This is 0, comma 0, as you already know, right? This starting function is 0, comma 0. And what exactly this is? This is 2, comma 6, right? So if you see what the robot now can do, robot has two options at any given point. At any cell, the robot has two options. Either the robot can go down or the robot can go right, right? The robot can move either down or right at any point. So if we are standing at this position, right, this is 0, comma 5, it can either go down or it can go right. At this position, either go down or go right. Okay. So why do we like I've already gave you a disclaimer basically. Why are we using recursion here? That is something that is important. Right? There are how many cells exactly? 0, 1. There are 0, 1, 2, 3, 4, 5, 6, 7 in 1, and 7 into 3. That is 21 boxes, right? 21 boxes. For each and every box, there are two options. There are two options. Either the either the robot can go right or the robot can go down. Right? To test all the possible cases, what do we exactly use? So for people who don't know, we use recursion. Now, why recursion? Because we need to try out all possible ways. We need to, this is something that is important to understand. We try out all possible ways and then we calculate our answer, right? Great. Time complexity, space complexity, that is something we'll understand later upon. But I hope you understand this point that for every cell there are a couple of things that we can do. Either we can go down or we can go right. Probably if it was given in the question, maybe other things as well, like going up, going left, whatever. You can, the question can vary from n number of things, but the main point to, you know, the main point to hold here is that you have to try out all ways, and then what you have to do is you have to basically do all your research, basically all your things, like probably, calculating the unique paths, or maybe if it was given in the question, the maximum or a minimum or whatever, you have to finally do all the things with whatever whatever answer you got, right? Great. There is one more thing in recursion that we understand, right? Recursion is top down approach. I know it's a jargon. You won't even understand why we are taking this jargon. But I'm sure for people who have already done some part of recursion, I'm not saying dynamic programming or any other language or any other algorithm. I'm just saying recursion, right? So for people who have already done some recursion, they would know that we reach at base case generally the last thing that further which the robot, in this example, the robot cannot go. Now, let's just say I am given 2 cross 2 matrix, 2 cross 2 matrix or grade whatever. I am here. I need to reach here. This is my destination. This is my, this is my, what do you call that? This is my initial point and this is my destination, right? I hope you understand, right? So, what is it? 0, 1, 0, 1. Now, what is this? This is 1, comma 1. So, to understand what top down is, where will I start? I will start from here, right? Now, if I start from here, what can I go? If I can go down, what is the opposite of down? I can go up, right? If I can go right, what is the opposite of it? I can go left. Same, like in this example, had we been standing here, what could I do? I can either go down or I can go right. That is how I reach this point. So similarly, to reach this point back from the destination, I will go left, right? Similarly, for this, I could go either down or I could go right, right? But to reach from destination, to reach this point, I will go up, right? This is what it is. Great. Now, what there are two things that this point can do. Either it can go up or it can go left. No, no, I don't think you have any problem in this, right? So to go up, I think the row, I think you already know that the row will reduce. So we say that hey, 0, comma 1, right? Column says same, but row changes. For going left, the row remains same, but column changes. The column will become 0. Great. Now this also has two couple of things to understand. Right? So it will either go up or left. So if going up, it says -1, then 1, and for going left, it says 0, comma 0. Great. Same, this thing either go up. For going up, you will say that this is 0, comma 0. For going further left, it will say 0, comma, oh sorry, -1, comma, no. So going left, what does it mean? From 0, 1, we are at this position. So going left here, minus 2, no. So 1, comma, minus 1, right? Now understand one thing. This is a grid, right? This is a grid. So minus 1 would occur somewhere for row, for column. Minus 1 would occur somewhere here, for row somewhere here. I hope this is understood. So minus 1 for row and column must exist out of bounds. Can this is this possible? Is these two things possible? So you will say no. So what is the thing that we can return from here? Is this a path? No, it is not a path, right? This is not a path. You are not reaching 0, comma 0. You are reaching somewhere out of the bound. I will say simply return 0. Great. This also returns 0. I can use different colors, right? I can use different. Great. 0, comma 0 are two ways. Basically, we have got two sub problems or sub solutions that reach 2 points. That reach 0, comma 0. That is our final destination now. So, what was the initial destination at the start of the question? It was 0, comma 0, right? But we started from the destination. The source was destination now. Now what our destination will be? It is now going to be 0, comma 0. Our source will become the destination and destination becomes source, right? So 0, comma 0 is the position that we need. We have reached, we have reached there. Now consider if I'm going out of bound, what I return 0. So if I return, if I return to the destination, the final destination, I am at the right position. What will I return? I will tell my I will tell what can I can tell my parent to call the person who called me, right? This person called me. This is my parent, right? This is my parent for this thing. I can tell my parent that yes, I am your solution because I am the place where you needed to reach. So I can return one. I can return one. Similarly for this 0, comma 0, this returns one, right? This returns one. Great. You will understand now. You need to understand one more. This parent, this particular parent, tried out two things. Tried out two things, either go up or go left. Similarly for this parent tried out two things, either go left, either go right. Right. Now to calculate the unique path, right? To calculate the unique path, I need to add it up. I need to add my solutions. Whatever my up and left gave me, I need to add them up, right? Very easy. So 1 plus 0 gives us nothing but 1. Similarly for this, 1 plus 0 gives us 1 plus 0, 1. Great. Again, this parent, for our case, it is a final parent. This parent again tried two things, either go up or go left. Right? What was the thing that we did? We need to add or we tried up and left. We need to add it up. It becomes 2. uh, 2. Now let's understand, is this the right answer? So let's just say we are not using any recursion or anything. We are just at 0, comma 0. Now our robot is at 0, comma 0. What could it do? It could go right, it could go down, right? It could go. So this is one solution. Sorry, this is one solution. Now this robot could also go down and this could also go right. This is second solution. Now at this position, our two things are exhausted: going up or going left. Sorry, going down or going right. At this position, we have exhausted only one thing. Can we go right now? We can try right, but again, it is going out of bounds, so no need to try it. Similarly, at this position, we can go down, but again, it is going out of bounds, so that will not be a unique path. That is not a path, basically, not unique. I don't care if it's unique. It is not a path at the end of the day, right? So we have finally said, concluded that the answer, if we dry run things, it is two. From recursion also, I'm getting two answers. That means I'm somewhere right. I can use recursion. Now, what is top-down approach? We need to understand. We need to try, we generally go from up, that is the last thing. Now this was a destination, but this turned to source. And similarly for this was our source, it turned into destination. When we try out all the things, starting from the last thing, starting from the destination to the source, you just understand this thing. When we go from destination to source, that is top down, right? When we go from source to destination, it is bottom, right? I hope this is clear. You don't need to get into details of it, but you need to know what is it calculating. It is going down, down one position, down two positions, then calculating everything. Great. Now, to understand recursion, we will write a code. We will write a code. Let's understand. Okay, fine. Let's first, what we can do is we can first write a code. There are three things to mainly understanding recursion. Number one, express everything in terms of variable, or you can say point, right? Point. Now, what is this? What does this mean? You can see at every point two or either of the two changes. Either this is, let's just say this is row and this is column, right? This is row, this is column. Either the row changes or the column changes. Either the row changes or the column changes. Row column. Either one of it is changing, right? So we can say that I comma j will be our two things that are changing. So I can express it in terms of variables or pointers. Great. Now second thing, do what you, or we can say perform all the possible things. Mm, I think this is self-explanatory. Like perform all the possible things, right? Now, what does this mean? You need to understand this. What were the what were all the possible things that was present at any point? At any point, it was either go up or go down. Sorry, either go up or go right for recursion. We, since we are writing for recursion, we can say that it was either go up or go left, right? So so we can here mention that either go up or left. Great, right? And lastly, this is the final thing. Perform or not perform, sum it up, sum all the possible things up, slash get the minimum or maximum or whatever is mentioned or whatever you have to do, right? And I'll tell you one thing. I'll tell you one thing, right? This is recursion. I'm not getting the term in English, but it's called Rampart in Hindi. For people who understand Hindi, this is Rampart. Now, what is Rampart basically? This is the thumb rule. Now, thumb rule. Three things are you need to know all these three things on your fingertip, right? First is express everything in terms of pointers. Second, perform all the things, what all the possible things that are mentioned in the question that you have to do. And third, maybe sum it up or do whatever you have to do with the final what you have now, with the final solution, right? Great. Let's try to write down the code. F I comma j, right? Function. I am not giving it any name. You can name it later. First is base case for every recursion, just to not send it to an infinite loop or infinite stack, basically infinite recursion stack. You need to define some base cases. Now here there are two base cases, and I've already explained to you what are those base cases, right? Either you will get a zero or you will get a one. And do you remember it? So either you return a zero or you return a one. Now what was those? Let's try to understand. If I is equals to 0 and j is equals to 0, return 1. Now, what does this mean? This means that we have reached the destination. Destination, right? 0, comma 0 is our destination. You will see that I've mentioned 0, comma 0 and I is 0 and j is 0. I'm not adding or. Else, not else, sorry. Another base case. If I is less than 0 or j is less than 0, return 0. Simple. If we are going out of bounds, if I becomes less than 0, that is, we are decreasing our row, we are going left. If we are going up and it increases our, it goes out of the bounds of the grid, we return simple 0. Right? So we have written a base case. Now, two things that we needed to do. So, express in terms of pointers. Uh, I can change. I think I should change. Yeah. Express in terms of pointers. So, first part, done. Perform all the things. Now, second is perform all the things. Right? I can use it. Yeah, green. So, what was performing all the things? Either go up. Well, now, what is going up? Up is nothing but I minus 1j. The row decreases. The row decreases. This is very easy to understand. The row decreases. Or go left. That is, column decreases, but row stays same. Right? So, I think we have done perform all the things as well. This is performing all the things. Great. Simply return up plus left. Now, what does this mean? We are summing it up to get a final answer, to get all the unique paths from which whatever things we tried. This is also done. So, three things are done. Express everything of variables or pointers, perform all the things, return the sum or whatever you have to do. Right? What is the time complexity is something that we need to understand. Great. To understand the time complexity, right? To understand the time complexity, you need to know something very easy. At any point of time, at any point of time, let's just say this is a cell F1, comma 1. Doesn't matter if N and M, what is the N and M, it is going out of bounds or whatever. You just know one thing, that you are at this particular cell. Okay? This cell has two things to go. Either go up, sorry. Okay, yeah, we are writing recursion. So either go up or go or go left. So basically, this boils to two things that any basically there are two possible things that a cell can do, that the robot can do on that particular cell. Right? Two things. There are only two things. Remember this thing. Two. How many cells are there? How many cells are there? There are n cross m matrix. This is the n cross m matrix. So for every cell, there are two possible things, and there are n into m possible. So 2 for 0, comma 0, 2 for 0, comma 1, 2, 2, 2, 2, 2, 2, 2, 2, for n into m. This is 2. Now, how many 2's are there? These are nothing but 2 into n into m, or m into n, whatever is given. I hope you understand. Right? Now, what is space complexity? This is something that you need to understand. Okay. At this position, right? At this position, it can go up, it can go left, up, left, left, up, can't go, left, can't go, sorry, can go left, 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 three, right? Up can go left, up, left, up, left, up, left, up, left, up, left, can't go, right? Again, this can go left, up, So these many situations are there. Let's just take this path, simple path, right? So this is what? This is how many steps did we take? One, two. So two steps. One, two, three, four, five, six. Six steps here. Six steps here. Right? Similarly, for everything you will notice that you will take only for going up, you will take two steps. For going right, you will go six steps. Right? At math. So simply, space complexity is nothing but this is O of m minus 1 plus n minus 1. I hope this is clear. I hope this is clear that you are going m minus 1 places and you're for left you're going n minus 1 places. So this is our space complexity, right? And this is our exponential x o sorry exponential time complexity. Understood. Great. We have understood this. Is do you think exponential can work? Now let's check out what is our NNM given. NNM given are 100. Let's just say we have a solution for 100 into 100. What is 2 to the power 100 into 100? It is 2 to the power, sorry, 2 to the power 1 double zero double zero, right? Let's try to understand what is this, right? 2 to the power 1 double zero. Mm, maybe. What is 2 to the power? This is the answer. This is the answer, right? For any for for any second, can you think that this will be a possible thing to even calculate? The answer is definitely no. Definitely no. Now here we use dynamic programming. Why dynamic programming? There are two things in dynamic programming. Okay. One is overlapping solution. Now what is overlapping? Right? Uh, Give me 1 second. Give me 1 second. Yeah, I'm really sorry, guys. See. So, where was I? I was at like, how can you determine that this question is going, this recursive solution can be further boiled down to dynamic programming. Now, what is dynamic programming? Dynamic programming is consisting of two things. One is optimal substructure, and second is um, overlapping subproblem. Optimal substructure that you have an optimal solution for it, very easy to understand, doesn't matter. But 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 overlapping subproblems. This is something that you need to understand. Let's just take this example only. Doesn't do you don't need to go any further down, right? F comma zero F00 is here also, is here also. Can I find any other example that is there? No, I cannot find, but eventually you will find another examples also, right? If I have solved F00 here, do I need to solve again? Do I need to solve here again? I don't think so, right? I don't think so. Because if I solve it here and I solve it here, then I'm already going to exponential power and I'm already going to exponential power, right? So if this is a subproblem, this is a subproblem. And these are overlapping. Now, why are they overlapping? Because they are consisting of same things, but they need to be calculated again and again. So this is called overlapping subproblems. And then I think you understand that these two things are consisting of if we can convert it to a DP or not. I will not go down into DP. I will just write a memoization code. What you can do is you can have a DP of n cross m. For people who are thinking that it was given m cross n and why am I taking n cross m? I am simply making a mistake. So this should be n, this should be m. I'm sorry, right? N cross m, and you need to take it. Now, what was a DP? What was a cursive code? Let's try to write it here. Let's copy it and let's try to paste it here, right? Okay. This we have initialized it. Not in this thing, not in this not in this function. You when you will call this function, you will pass dp in that function only initially, right? So base cases should be written as same, right? But here one line will be. Now what is that line? Okay. Now that line is that if, and obviously, yeah, sorry, you need to initialize everything with -1. All the answers should be initialized with -1, or maybe initialized with integer dot minimum safe integer, right? Minimum number dot minimum safe integer, whatever, right? If let's just say I'm initializing it with -1, if dp of I j is not equal to -1, then simply return dp of I j. What is this? This is and you need to understand this thing. You need to understand this thing. Okay. What is this problem solving? What is this solving? This is solving our overlapping subproblem part, right? That you have already calculated. Do you need to calculate it again? I already have a solution for dping d, and that is not minus. That is something either it's zero or it's one or whatever it is. You need to calculate it. You need to calculate it again. But here I'm saying that hey, I have already saved it in my array that I've created, that is a DP array. I've already created a DP array, and what you need to do is you can save it there. You can save it there, and for at any point of time, if you need it, and if it's not -1, you can use it. You can use it. Great. Now, to save it, what will we do? We will say that hey, DP of I and J is equal to up and left. To save the answer, we will have to do something. We will have to do something, and that is what we are saving it here. This is our memoization code. Now, what is this? This is nothing but memoization, right? This that we are memoizing things. Now we are memoizing things, aren't we? We are memoizing things, right? This so we at this point we are memoizing. At this point we are taking care of the subproblem, right? Great. Uh I will not go down to time complexity, space complexity, and then to tabulation and then to space optimization because it's not a DP class. I will cover it. Don't worry. I will cover it. It will be on my channel very soon. Don't worry about it. Let's try to go down to the main thing that we need to do here. The main thing that we need. Great. Uh, okay. Let's take this example. A 2x2 matrix, right? Robot is standing here and it needs to reach this point, right? Sorry, let's not D. Let's say this is the final, final thing, right? This is the solution. Great. It can go down, it can go right, right? Great. I will say that hey, it goes down at this point. What is it? This can go down, this goes right. I will say go right. Right. This point again, either down or right. I will say go down, this goes down. I will say go right. What was this? This was a 2x2 matrix. And for 2x2 matrix, you will notice that you use two right and two down. Okay. This is you will say, hey, you are just playing around. Okay. Okay. I was at this position, right? I could go right. Great. I could go right again. I could go down. Let's just say I go right again. I am now at this position. Can I go right? No. I can go down. Can I go right? No. I have to go down. Great. I was at this position. I could go down. Right. So R and D. I could go right, I could go down. Let's just say I go down. I go right. I have to go right from this position. Let's just say I go right, and then down. So for every solution, you will notice that right is coming two times, D is also coming two times. And this is not a 2 cross 2 matrix, this is a 3 cross 3 matrix. I'm sorry. Right? This is not a 2 cross 2 matrix, this is a 3 cross 3 matrix. There are nine cells and not four cells. Right? Right. What does this mean? This means m minus 1. This means n minus 1. So what is our m? What is our m? It is nothing but 3. What is our n? It is 3. Right? I can go down, or is it n minus 1? No, it should be n minus 1 for right, and this should be m minus 1. Sorry. For every row changing, I can go, if I'm going down, that means I'm changing my row, I'm changing my rows, it will be m minus 1. How many times can I go down? It will be m minus 1. How many times can I go right? It is n minus 1. Right? Hope you understand this point. For columns changing, you are changing the n. That is, you are changing across n. You are changing across m if you are going down. You are changing across rows. I can say that at any point of time, how many things can I do? I can say n plus m minus 2. What is it? Now, what is this? If R is used here, DD is used here, I have 2R and 2Ds. I can say this is the final solution combination. That is NCR. I hope you understand what NCR is. For people who don't know, NCR is permutation and combination. You can go on Google and you can read about it. Now, what should N be here? I told you N minus 1 or M minus 1. Does it matter what N and M is? Does it matter what N and M is? No. I mean, as in, does it matter if we are taking N or we are taking M? It is going to be N minus 1 only. I can say that it can be n minus 1 or it can be m minus 1, whatever. The answer will be the same. The answer will be the same. Let's see what it is. What is n here? What is n here? It is nothing but 3 plus 3 minus 2. It is nothing but 4. So 4. See, what is n? It is 3. So 2. What is 2? Let's try to understand. 2 cross 1, we will say that, hey, open for two times. Now, okay, I need to make you understand this as well. Let's, right? This goes by 12. This is the answer. But you will not know, right? You will not know how many things are there. We did for, we did for, what was it? It was 2 into 2 cross matrix, right? To 2 into 2 cross matrix. So 2 plus 2 minus 2. So it is nothing but 2C1. What is 2C1? 2 into 1 upon 1. Is this same? Yes, it is. Yes, it is. If we take an example of 3 cross 2, 3 cross 2, let's just say. So 3 plus 2 minus 2, C, what is M given here? I'll take M, don't worry. So M is 3. So 3 minus 1 is 2. So 3C2 is nothing but 3 into 2 into 1 upon 2 into 1. What is the answer? 3. What is my answer? 3. Have we found a solution? Yes, we did. Yes, we did. Now, you need to understand 3 things. Let's just say if I write 10C8, 10C8, right? Hmm, how can I make you understand? Mm, 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 mm. Okay, you don't need to even understand this. We can take it out later. We can take it out later. Let's dive into the code. Let's dive into the code. Basically, it's opening 10 into 9 into 8 upon 8 into 6, 7 into 6, blah blah blah, right? Okay, whatever it is, right? You can read more about it on internet, like how to easily solve it. But I'll just write down the code for you. You don't need to understand all these things right now because this is not the part where you need to understand it. You will have particular dedicated questions for permutation and combination. There we will learn about. So let stress. We'll say that hey, stress is equal to one, right? Because we are multiplying. Now we are multiplying. Great. Okay. Now I'll say, mm, let R, we know that NCR, this is what NCR is, right? So we'll say that, hey, N, what are you? You are nothing but N plus M minus 2. What are, you are nothing but M minus 1 or N minus 1, whatever you want to take, doesn't matter. Or N minus 1, whatever. So I'll just take M minus 1. I'll start my loop, let I is equals to 1, sorry, I is less than equal to R, I plus plus, right? Great. Now I'll say that, hey, res is equals to res into, res into. Now what is res into? It will be n minus R plus I divided by R, divided by I, sorry. So n minus R, is it plus I or plus 1? Okay, let me consider it. N is, let's say we have 2, okay. So it should be, no, it should be not I, it should be plus 1. Sorry, divided by, great. Let's try, and at the end of the day, we'll just return. Doesn't matter. Let's try to understand. Again, we are given a 3 cross 3 matrix. We already know the answer for it. So we'll just say, what is n? N is nothing but 3 plus 3, that is 6 minus 4, so it is 4. And what is this? This will be 3. Sorry, this will be 2. This will be 2. N minus 1 or n minus 1, whatever. You start from 1. So R is I, sorry, I is 3, sorry, it is 1, right? Rest is 1. So 1 is equal, rest is equal to 1 into n. What is n? N is 4. 4 minus 2 divided by I, that is 1. So it is nothing but what it is now? It is 2, right? So this becomes 2. Great. Again, now I plus plus, so it becomes 2. Rest is equals to rest into, so 2 into n. What is n? N is 4 minus r. What is r? Minus 2. Oh, sorry, plus 1 here. It was plus 1 here. N minus 1, n minus r plus 1. So it should be 3. And it should be 3. So it is 3 into 4 minus 2 plus 1. That is, again, nothing but 3 only, right? Divided by I. Now, what is I? I is 2. So 3 into 3, 9. 9 divided by 2. It is nothing but 9 divided by 2. What is this? Am I making some mistake here? Am I making some mistake here? Because it's either 4 or plus 5. Mm, okay. Okay. Give me 1 second, right? Give me 1 second. I'll just figure it. I'm sorry, guys. It was not plus 1. It should be plus I only. I think I made a mistake there, right? So let's start from the starting. It doesn't matter. Oh God. Why it takes so much time? When I am on Zoom, my laptop hangs a lot. It is very slow. Not sure why. Okay, this also. Doesn't matter. We'll just take. So it was 3 cross 3, right? N was 3 plus 3 minus 2 to A, and this is 2 only. So it doesn't matter. So I is nothing but 1 right now. What is the rest? Rest is 1. So 1 into N, that is 4, minus R, that is 2, plus I, that is 1 upon 1. Okay, doesn't matter. It is nothing but 3. So rest becomes 3. Great. Now this becomes 2, right? So what is rest? Rest is 3 into N, that is 4, minus 2 plus 2 upon 2. This cancelled. This becomes 2, right? This becomes 6. But our answer for this was 12, right? 12. Why is it coming as 6, bro? R is 2, so we are going to equal to 2. Rest is equals to rest into, that is 3 into. Am I making any mistake? What is that mistake? Let's try to figure it out. Okay, this is 1. So I know for 2 cross 2, right? So I know cross 2 cross 2, it will be 1. Then I am just pausing it because. Hello guys. I think there was some mistake here, right? There was some mistake here. So when we were taking 3 cross 3 matrix, the answer that had to be the had so 3 cross 3 matrix, right? What what was that? Then we what we took? This is 3 cross 3, right? This is 3 cross 3. So what is n plus m by 2 minus 2? It is nothing but 4c and nothing but c is n minus 1, that is 2. Now what is 4c2? 4 into 3 into upon 2 into 1. Oh, okay. So 4c2. Sorry. I did one mistake. I did one mistake. And I know what it is, right? And I know what it is. I'm really sorry. I now can make you understand what it is. Sorry, right? So see, if you are given 10c2, right? How many numbers are written here? 2, right? Open 10 into 2 times. 10 into 9. Opened. Great. Ne You can write it as 2 into 1. For R, you don't need to understand. This will be nothing but 45. If had it been 9C3, how many times do I need to open 9? Open it simply 3 times. So NCR is basically N factorial upon R factorial into N minus R factorial, which I forgot to do here, and thus I got the answer. So it should be 2 into 1 again. N minus R. What is N minus R? N minus R is 4 minus 2, that is 2, and 2 factorial is 2 into 1. So I had to cut it again. So this becomes 2 and this becomes 6, right? This was my mistake. I'm really sorry for that. So NC3 is nothing but 9 into 8 into 7 into 3 into 2 into 1. So 4, 3. What is 3 into 4? 12. 12 into 7 is 84, right? This will be our answer, 84. So the code that we wrote here is opening n by r times. This is what this code means, and you can see here I have run the code and I am getting accepted solutions. Let's try to submit it. Okay, I'm submitting it in front of you all. Great. We beat 96.64 users of Java. I hope this was somewhere an easy question from because from now on you will get a difficult maybe difficult question. Start from recursion, express in terms pointers, variable, do all the things required. Sum it up, right? Then convert the solution to DP, then move to space optimization, which is taking only in consideration of the previous row plus current row. That's it. I haven't made you understand this, so probably you don't need to understand this, right? Then the final solution is based upon permutation and combination. So n minus m, n plus m minus 2, c, r is m minus 1 is the answer, right? Is the answer. Can I make it bold? No, I cannot. Okay, this is something that opened. How do I send it back? Okay, just save it. I'll deal with it later on. This is this. Let's mark it as done. I hope you understood the question and you were able to understand how to, solve questions starting from recursion, and then you can go upon, um, basically, then you can go upon I just stop sharing. Then you can go upon the final solution. Maybe the solution was not a permutation combination. What was the first thing that should come into your mind? It should be recursion. Why? Because you are trying out everything possible. You are trying out everything possible at every given cell. So try out recursion, then go on to deep dynamic programming, then go to tabulation, that is also DP only, then go to space optimization. And then if you have any other solutions in your mind, then go on to your permutation and combination solution for this particular question. I hope you were able to understand. I'll see you tomorrow with another question that is called reverse pairs, right? Okay, right? See you tomorrow. Bye bye. Thank you.